On to topic 4 of chapter 4. We're dealing with absolute value equations and inequalities. And that's what we'll be looking at. So as we scan this a little, we see absolute value signs and equations. In example 1 and in example 2, we'll see our inequalities. And to give some background, what is an absolute value? Well, by definition, an absolute value is set up by having something in between two vertical bars. And this is an operation saying, take the absolute value of this, and what will it be? And the answer is it's always going to be a positive value. Now, it could have been, as you might recall, a -3 or a +3, and both of these are going to be the positive value. So a little background, that's from chapter 1. So let's see what they're asking here. For in letter A, they're saying x, the absolute value of x equals 2. Now, we need a protocol, a method of operation, a strategy to set these up to how we solve. And the basic rule is write it without the absolute sign. We just took the absolute sign away and we're writing it. And then you write the word or. It could also have been x was equal to the opposite sign of what is there. And that would be a -2. And those are your answers. Now, as we look at letter B, here they're giving us sort of a contradiction. They're saying the absolute value of something is a negative something. Well, we just finished defining absolute value of something as always its positive value. So when you see something like this, the absolute value of something is equal to a negative, this is a no solution, because that's sort of an untrue statement. And then the absolute value of 0 is 0. And we don't have a plus or minus 0. So these are just some background things for you to be aware of. Now, as we go into letter D, the absolute value of x minus 5 equals 2. So what will the protocol be for doing this? Well, as we said, you write it without the absolute sign, and you write it with the part on the right, the opposite sign, or the negative. So then you get these two equations and you just solve them. So x equals, transpose the -5, you get a 7. Transpose the -5, you get a 3. So again, transposing this or adding 5 to both sides, that's what happens. And we're just giving you some examples of how to do it. So there's the example. We're going to write it twice. And this is how you should set up your notes. So 1 without the absolute signs, 1 without the absolute signs, but you have the negative value there. Now remember, you can't start with the negative value, but once you remove the absolute signs and are working the example, you can put the negative value. In fact, that's what you're supposed to do. So this becomes then 2x, transpose that, positive 3 makes it a 10, divide by 2. Now here when it goes over, it's a positive 3, so this gives you a negative 4, and that becomes x equals a negative 2. Now, once again, when you see letter F, they're saying the absolute value of something is a negative. Can't have that. So this is no solution. And here's another. There's not that many, so we'll just do it. X minus 1 equals 6, or x minus 1 equals a negative 6. So here we transpose, x equals 7, x equals a negative 5. Now in the case when you get two absolute value signs, as we see here, the protocol, the way to do it is you write it first without the absolute signs. We're just taking the absolute signs away. Or, now x, 3x, this part stays the same, 3x minus 1. But now on the other side, here, you're going to say a negative, and then put what's in the absolute signs in a parenthesis. So you're following the same procedure, that is, replacing this with a negative, and we have to do that by putting all of what's there in a parenthesis. So what does this become? Well, this is going to become a negative x and a negative 3. A shortcut might be just put a negative there and change signs, whatever's there. Okay, so let's just do these now. Here we're going to transpose that. That gives me a 4. Transpose the x. This gives me 2x. So x equals 2. Now here, when we transpose this negative x to this side, it becomes a 4x. Transpose this to this side, it becomes a negative 2, because this on this side becomes a positive 1. And then we divide by 4, we get x equals a negative 2/4, which will be a negative 1/2. Okay, so we're giving you the review of how to do these. And again, the protocol is to set it up like this. This is what you want to have in your homework log as you do it and in your class notes. Okay, so here's another example where they're giving us an absolute value example in function form. So they're saying the function of this such that it will be this. So you just set it up like that. So 3 absolute value of x minus 2 absolute value of negative 3 equals 9. Just kind of clean it up a little bit. So we're going to transpose this negative 3 here to the other side, and that'll give us a 12. And then we have x minus 2, like so. Now we're going to divide both sides by 3. And then we get, let's see, I'll put it over here. We get x minus 2, the absolute value, is equal to 4. Now, from this we go x minus 2 equals 4, or x minus 2 equals a negative 4. Okay? And now it's easy to solve. X equals 6, just transpose that. And here x equals a negative 2. All right, we'll be going on now into solving and graphing inequalities. And to give you the strategy for doing these, well, in letter A, it's going to be absolute value of x is greater than 4. Well, this gets translated in a sense to x is greater than 4. We're just taking away the absolute value sign. And now we're going to have to reverse the inequality sign from greater than to less than. And this is going to be now a negative 4. So we had some like this in the previous section. So we're going to graph this now. There's our number line. We want a negative 4. We want a positive 4. And then what symbols do we want here? Well, we're going to have a parenthesis. X is greater than 4 would be a parenthesis going this way. And this is x is less than negative 4 is a parenthesis going this way. Now, we call, when we have the absolute value is greater than something, we're going to end up with what we call a disjunction. So when we go to put that in interval notation, it's in a sense a union, which would come from negative infinity up to negative 4 with a parenthesis since it's not included, union 4 is not included, that's why we use a parenthesis, up to positive infinity. And that is for letter A. Now notice for letter B, the inequality sign is reversed from here. It's absolute value of x is less than 5. Here we get a conjunction, and let me work that for you. So absolute value of x is less than 5 will become absolute value, or x is less than 5. And the word here now is we're going to put and rather than or when it's a less than for absolute value. And it appears x is greater than 5. We have to reverse the sign, and that would be a negative 5. Reverse this sign, and then opposite sign. So when we graph that, we're interested in a negative 5, and we're interested in a positive 5. And it says here x is less than 5. So we're going to go this way. And this is x now is greater than a negative 5. So we go this way. And this is what we have. And in interval notation, it's parenthesis, negative 5, comma 5, parenthesis. And Let's check what they have down below too. Well, right here for letter A, they're giving us this one. Now, if we were to put that in set builder notation, it would look like this. And I wrote this one again, but this is down here as well. Okay, let's take a look at letter C now. And we have the absolute value of 2x plus 6 is less than or equal to 12. Now, let me ask you this. Looking at the inequality sign, would this be a disjunction or a conjunction? Well, it's like this one. We said this one was a conjunction. Greater than is a disjunction. So this is going to be a conjunction. And we solve it as if we would a equation, write it, 2x plus 6 is less than or equal to 12. So to work this with you, this one, and then reversing the inequality sign and using the opposite sign. So we get here 2x subtract 6 is less than or equal to 6. X is less than or equal to 3. And this one is 2x is greater than or equal to, now as we subtract 6, or transpose that, that becomes a negative 18. We get x is greater than or equal to negative 9. Okay, so graphing it, we have our negative 9, we have our 3. Now, since this is a conjunction, we're going to be filling in between these. And in interval notation, it's negative 9, comma, 3. In set builder notation, you're having it as brace. X is such, that's what that vertical line means, X is such, and it's starting at a negative 9, and you're going to put in these signs. Less than or equal to X is less than or equal to 3, and brace again. And I believe that's what they have right there. And right there. Oh, I didn't do this one right, did I? Sorry about that. Because you pick up your interval notation right from the graph. The graph is a good source, and just copy it correctly. Okay, on to our last one, which is similar to what we did before. It's the use of function notation in which we are saying absolute value of 4x minus 3 is greater than 2. Now, is this going to be a disjunction or a conjunction? Well, because it's greater than, it's going to be a disjunction. And we'll work it out. So 4x minus 3 is greater than 2. And then 4x, this is going to be an OR. 4x minus 3 is less than negative 2. So solving it, this goes over to this side, and becomes a 5. So x is greater than 5/4. And this one we bring over a negative there. On this side it becomes a positive, so less than 1. X is less than 1/4. And I can see it down here too. So to graph this, and the nice thing about when you graph it, you can just put your numbers wherever you want. 1/4 is right there. 4/4 is right there, or 5/4 I should say. It's like about a 1 difference between them. And here you're saying that x is greater, so it goes this way. And here you're saying x is less, so it goes this way. And again, this is a disjunction. And in interval notation, this would be from negative infinity up to 1/4, parenthesis now, union, parenthesis, 5/4 to positive infinity, right from the graph. And we did show you this down here as your set builder notation. Okay, you'll be doing some practice, and I believe your tests now on Module 1 is your next step. But you want to have your mastery completed. And again, any questions that you have, bring into Math Lab or address here in classroom. Okay.